Hey, what's up guys? Tegan here from Rocky Mountain Astro. It has been a long time since I've uploaded anything, especially a post-processing video, so I got my hands on an S2 filter a few months ago, and I'm going to be going through my full narrowband post-process workflow. I'm going to go ahead and do this into, divide this video into about 5 different sections just to make it a little bit easier to follow. I will be utilizing Starnet as well as Topaz AI Denoise, which I have found, it's becoming somewhat popular to use for astrophotography, and I find that it really, you can over process your images with it very quickly. So you have to keep it, you have to be conservative when using that tool from what I found. So I'm going to see what we can do with it and see how we can introduce it into our workflow, and hopefully you guys can follow. This is not for people who are, imagers who are new to PixInsight by any means. You may be able to follow along, but this is mostly a video showing my personal workflow, and hopefully you learn something from it. So the first section is going to be image prep, followed by uploading our videos into Starnet, and then we're going to be doing Topaz Denoise, and then some color correction, and then adding the stars later into Photoshop. So I'd like to keep this under 20 to 25 minutes, but we'll see how that goes. So I'm going to go ahead and start off and show you guys the data that I got, and I took 12 hours total. I collected 12 hours of exposure time in SHO, and this is on the Pelican Nebula. And this is through my ASI 1600 and my 10-inch Quattro. So that's my HA data, and followed by my S2 data, which turned out really well. There's a lot of structure. And as you guys know, O3 just sucks. O3 always sucks. Regardless of, exposure time, O3 sucks. So these are my 3 channels that I'm working with. Pretty happy with the noise, especially in HA. So the first process I'm gonna do is combine, because these are upside down, this is right side up. So I just like to go to process, all processes, and do star alignment. And as my reference image, HA, I want to combine everything to match my HA channel. So I just go to reference image. I've already selected HA here, and I just drag and drop. Shouldn't take too long. And I'm going to do this with my O3 image as well. Sometimes it doesn't work and you have to increase the star detection threshold. Okay, so my S2 data is registered. Set that over here. Minimize that. I'm going to set this over here because we're not going to need that. And then I'm going to go ahead and run the star alignment process on my O3 data. And we are not going to need this channel, or this image, because it won't be registered. We'll use this one, subtract that, move it over. Okay, we don't need this one, and we're just going to move this aside. Alright, so now as you can see, I'm going to bring this down to match. These were all, just temporarily stretched. I am still in the linear state, so I have not stretched these. Exit out of this, but I am going to right now. And the tool I'm going to use to stretch these is masked stretch, and that's in process. So I'm going to go up to process. Where is it? Mask stretch. Okay, and I keep everything the same, and then just drag and drop. And it's not a crazy stretch. You see, it's pretty conservative. It's not too bright, but you can adjust this manually if you like. I do like stretching a little bit before I combine in pixel math, which is what we're going to do next. And these all have darks and flats and bias frames, so there shouldn't be too much gradient. If there is, then you can use background extraction to eliminate that, but I don't think there's a need to for these images. Okay, so I have my HA, my S2, and my O3 data stretched. So what I'm going to do now is I'm going to combine the three images using pixel math. And process pixel math, uncheck this. I go to expression editor, and for red, this is an SHO palette, so red is sulfur. I'm going to choose my registered. Make sure you're choosing the right one with your star aligned final image, otherwise it'll, you'll have wonky colors. For green is HA, and for blue, O3. I hit OK, and then you want to change the folder in the output here. You go under destination. I'm going to create a new image here and just call this tricolor combined. Color space, make sure it's at RGB, and you can go ahead and run it. Alrighty, and close this out. Okay, so this is my combined image. I actually got some great color, got some great contrast, except the magenta stars. I'm not a huge fan of the purple halos, the purple stars. Some people like it, kind of looks, more Hubble-esque. This is a creative decision, and that's on you. If you want to eliminate the magenta stars, very simple. You go up to Image, Invert. The opposite of green on the color wheel is magenta, so, or red technically. So as you invert it, you see all these stars turn a green hue. You can go up to Process, and then Noise Reduction, SCNR, Color to remove, green, amount, I keep it at 1.0. Apply this, you'll see the green stars, they'll all change to kind of like a gray-blue hue. And then that's when the magic happens. You go to Image, and you invert back, and they all turned to a either a gray, orangish red, much more natural looking than those magenta stars, and I much prefer these color stars. So I'm going to rename this one because we are going to use it later. I'm just going to tricolor stars, and this is actually the image. We're going to save this. This is actually the image we're going to be using in Photoshop in the last step to combine, to introduce the stars, because we're going to be editing a starless image technically after we go through Starnet. So this is going to be the image you want for your to add your stars in later. Okay, so I'm going to save this. Let's see here. Yeah, so I'm going to skip, I'm going to save it, and I will be back shortly. And we're going to actually put this through Starnet. Now this is a process in PixInsight, or I think it might be a script. I actually don't have this. I go through my folder and I just go directly through Starnet. So actually, I'm sorry, before we go through Starnet, I want to increase the brightness on these just a tad. Going to just go to histogram transformation, do a live view, and I'm just going to bring up the midtones, ever so slightly. And same with my RGB image. Okay. All right. So I'm not going to show you guys, the Starnet process, run its course, because it takes 15-20 minutes, sometimes longer if you have like an i3 or an i5 processor. Okay, so this is my HA data, and this is my tricolor data. You want to save these and run them through Starnet, and I will be back with the Starneted versions shortly. Okay, so we are back from running the Starnet process. I'm going to go ahead and minimize these and show you what I got. Okay, this is my starless combined image, and this is my starless HA image. And what you can do here, honestly, I don't do, after the Starnet process, I don't do anything with my images, because I'm going to do that after I combine them. And you can If you don't have Topaz Denoise, what you can do at this point is process and sharpen, deconvolute, etc. your HA data, do noise reduction, get that looking nice and pretty, and use that as your luminance layer later. But for now, we're going to be using Starnet to see if we can sharpen and denoise and bring out the details. So from here, you want to save it, and then we are going to be uploading the HA image into Starnet. We don't need to worry about noise reducing and sharpening the color combined image simply because that's only going to be used for color. We're not using it for detail. We're using the HA data for detail. So this is effectively finished. I'm going to minimize this, bring it over here because we will be using this later and for color adjustments, etc. And then we're going to be overlaying our sharpened, denoised HA data onto said color image to get a final image, and then we're going to upload it into Photoshop. So go ahead and save your combined data, save your starless data of HA, and now we're going to go ahead and go into Topaz Denoise AI and edit our starless data. So I will see you in 2 seconds when I upload it into Topaz. Okay, so here we are in Starnet. I've uploaded my starless HA data, and you want to make sure you save it from PixInsight as a 16-bit TIFF file because Denoise AI works best with 16-bit TIFFs. So this is my 16-bit TIFF HA starless data of Pelican Nebula. And one more thing, this whole thing takes a while to render once you do your update as you're going along making adjustments. So you want to actually decrease your field of view so you're processing a smaller area. 75% is fine. This may take some time, even this small window to process. So right now you see the remove noise and enhance sharpness is set as a default at 15. I always kind of like to hit update and see what that gives me. The last, I've used this about 2 times for 2 of my images. One, I find it really helped. One, I just found it created some terrible artifacts, no matter what parameters I set these to. So from what I've tried, I feel like removing the noise, remove noise, that parameter should be set down to like 2 or 3, depending on how noisy your images are. Enhance sharpness, it really differs from image to image. So that's something you're going to have to play around with. Also, it'll say 100% here, but you click out. I don't actually see a difference here. All right, it's funky sometimes. Let me update this again. But yeah, like I said, this you can make your field of view, your little preview box smaller if you want the rendering to go faster. But then you'll have to test different areas of your photo. You want to see how it affects the dark nebula. You want to see how it affects the images that you're focusing on. So after it's generating preview, this takes a while sometimes for whatever reason. I might just have to update because it did ask me to update the version here. Okay, updated. So you go back and forth. Okay, well, to me that I don't know why it's not going back and forth. So what I saw there was too much noise reduction. I'm going to bring this down to 5, increase this to 20, and see how it works. I don't, too much noise reduction, it looks fake. So just, keep that in mind. Again, that's a creative decision. It seems like this noise reduction process is working pretty well on this image from that last preview that I just saw, but it was definitely too much, and you know, too much noise reduction can lead to a literally grainless image, and you know, that's somewhat unnatural in photography. So that's, you know, my opinion. A little bit of noise is fine. You know, I don't think I want to, you know, eliminate all of it. It'll just kind of end up looking plastic, almost like a painting. So we're waiting for it to generate preview. It says 100%, but it's clearly not. And I'm interested to see what the increase in sharpness is. Yeah, I tried this on my Heart Nebula last, and I found that enhancing the sharpness brought in a lot of gradients, so I only did, you know, very minute noise reduction, and it worked pretty well. And I think I ended up using Denoise AI in my final edit of the Heart Nebula, and I really liked it. But for instance, the nebula, the object that I shot before that, I think it was like NGC 7822, was just, you know, terrible. So I didn't actually end up utilizing Denoise AI. Okay, well, this isn't working. Let's click out. Okay, it actually did work. Okay, so pay attention, because I might not be able to toggle back and forth here. So this is with these settings, 4 and 21. And if I click on the image, it goes back. And I can't toggle. I can usually toggle. So I actually like these settings. I might increase the sharpness just a tad. Doing this with stars will completely destroy your stars. So just a forewarning. So once you get all of your parameters set, you go ahead and hit Save Image. And it's going to, you know, give you a name. You can name it whatever you want. I'm going to keep it Pelican HA Starless Denoise. Save it. It'll go through the process, and once it's finished with that, you want to upload it back in PixInsight. So that's where I will meet you guys. All right, so the denoise process is finished, and right here is my saved file directly out of denoise. So these should be, you know, in brightness almost identical. But if you zoom in, you know, let's see, let's do a direct comparison here. You know, you can see a different. Well, let's bring this out. Let's go over here. Okay, so you know, you can see a difference. There's noise in this one. It might be hard to tell from your computer screen, but to me, it's, you know, it's a nice improvement of, you know, a little bit of noise reduction and some sharpening. So I didn't go overboard with it because my data was pretty noise free to begin with. So I'm happy with this one. I'm going to go ahead and rename it HA Denoised, and this will be the image we work with. All right, I'm going to go ahead and move this over to the side. And so this is going to be the layer that we use to, you know, combine with our starless image. Now I'm going to go through and edit this for color and do any extra processing, sharpening, you know, dark structure enhancement that I want to this image. I'm going to go ahead and start here on my color combination photo and go through and adjust the color, saturation, darkness, etc. Or I'm sorry, midtones. I'm going to go ahead and start by bringing down the midtones because it is a bit too bright, I think. Okay, and there's a lot of green hues. I do like the green. I'm going to apply that, but only in the highlighted regions, if I'm being honest. And the cool thing about this is that it's a starless image, so you can actually bring up the highlights without saturating your stars. I usually never touch the highlights on an RGB image because you simply just saturate the stars unless, you know, you're masking. But in this case, there aren't any stars, so I'm going to adjust accordingly. And again, this is all creative decision. I'm going to increase the reds. I'm just trying to kind of get this area to pop. You can probably increase the saturation too. Increase the brightness there. Bring down the midtones a tad. Apply. This is all pretty iterative, especially histogram transformation or curve adjustments. I find that these adjustments are very small, but high in number, that is for sure. So I'm just going to take you through my process. Sorry if it's long, tedious. That's how color correction usually is. So increase the saturation a tad. It's a little bit purple over here. I'm not a huge fan of that, so I'm going to go ahead and decrease the reds. I like to select the linear interpolation tool. And instead of a curve, it kind of gives you a much easier ease of adjustment, especially in the darks. Instead, you know, you can go up and down, and it won't affect this top area. But for instance, if you have, you know, default selected, you'll see that it's literally a curve. So this gives me a little bit more control. So let's see. Yeah, again, I don't know what I like. I don't know that saturates it. Okay, maybe the blues. Let's see what we can do with the blues. Oh, I do like the green tones a tad. Man, it's these creative decisions are difficult. You know, what to eliminate, what to bring out. But then the blue tones, it looks so nice because, you know, it's nice and cool. You kind of have the Hubble palette look with the blues. You know, I really like that, honestly. And I want these areas right here to be somewhat green, you know, pop off with, you know, like a glowing, kind of like a glowing, this glowing ridge. Increase the green, the highlights a bit. Select this, bring this down. Oh man, again, creative decisions, it can be so difficult, but I've already, you know, completed and finalized this image, so I was really happy with what I got. But, you know, replicating that curve transformation from, and, you know, replicating that color palette that I had, you know, is almost impossible, you know. So you just have to make the creative decisions in the moment. So I'm fine with this. I like this color. Maybe a bit more saturation. Just a tad, and maybe increase the reds. Again, you can, you know, go forever. All right, that's pretty nice. Yeah, a little bit of purple hues, but it's the Hubble palette. It's almost like a rainbow. You're editing a rainbow. A gaseous, nebulous rainbow located 8,000 light years away. All right, you know, this might be a bit too saturated, but for this point of the video, you know, I'm done. So I love the color. And oh, I love the amount of, you know, just the Herbig Haro objects and these globules, these star-forming regions, and this wispy dark nebula. Oh, I'm obsessed with this data. The fact that I collected this in Bortle 8 skies, well, Bortle 7 is it's very surprising. It's what 3 nanometer filters will get you. So much structure. Okay, so I'm finished here with this color. I like the color here. So now, you know, keep this as is. I'm going to minimize that. My color data is finished. Now I'm going to do any last edits that I want to on my starless data of my HA stack. Again, pretty noise free. I'm probably going to brighten this up a tad. I want to brighten these regions right here. So I'm actually going to do a mask. First, I'm going to go ahead and brighten the entire image using histogram transformation. Live preview, and reset that. Okay, let's see. RGB, let's increase the highlights. So we can do that. And decrease the midtones. You know, maybe a mask isn't even required because you can increase the highlights. You don't need to worry about, you know, masking out the stars. So, oh snap. Pause. Hopefully I don't shut down. Hang on. Sorry about that. Let's plug this in real quick because my battery life is terrible. Oh, okay. Saved. Usually have about 15 seconds after that warning before my computer just shuts off. All right, that was That was a close one, you know, just one of many stupid mistakes you'll make in astrophotography. Okay, so back to it. Love the highlighted regions. I'm going to enhance these dark structures, which is pretty simple. I like to go to, it's a simple script, utilities, dark structure enhance. The default amount 0.4, iterations 1, 8 layers to remove. Just, you know, keep that at that. And if you haven't actually used the script before, what it does is it's just that it enhances the dark structures. So not only do you get contrast, you get a little bit of sharpness out of these regions, but also it can add noise to these dark regions, because, you know, there's not much signal coming from those regions since, you know, it's dark. All the signal's coming from here and these, you know, highlighted regions, these bright hydrogen alpha regions. So, you know, you can go back, you can increase the dark structure enhancement, you know, or you can decrease it here. Let's zoom in a little bit. Oh, I think that's perfect. So let's go back and forth and toggle between the two. Control Z. You can see it. Let's go zoom out a tad. Control Y. Control Z. So you can see the difference there. And it gives it so much dimension, in my opinion, especially down here. Oh, you see all these dark regions? Oh man. Okay, so yeah, that is perfect in my opinion. I'm not going to edit that anymore. Okay, so you have your color combined data. I'm just going to change the name of this. Pelican combined, starless. You know what, let's just call it, I'm just for the sake of the video, Pelican. You know what, I liked what it was called, Pelican combined starless. For this one, let's call it HA starless. Okay, so notice up here it says RGB. What we're going to do, when you go to, you'll see when you go to process, and what we're going to do is essentially just like overlay this data on top of this data, just like that, and we get a color image. So first you want to go to, you know, process to do this, LRGB combination, deselect RGB because you're using this as a luminance layer and you're going to apply it to your, you know, color image. But what you'll find, you know, you're looking for HA starless and it's not on here, because it's not in grayscale mode, it's in RGB. So what you want to do is extract the luminance, and it will pretty much duplicate this image and turn it into luminance data, which I feel like that's much sharper. Do you see a difference there? I definitely see a difference in these two images, and there shouldn't be. Let's see. I find that to be much noisier than that. Am I losing my mind? Are those identical? They're not. I know they're not. I can tell. This is... Oh well. Okay. So, assume yours is fine. I'm just going to make some adjustments to this actually. Go to process. Histogram transformation. Interesting. It's very weird why it came out like that. Okay. Maybe increase the midtones a tad. I just feel like this came out a bit more contrasty than this image did. So I'm gonna apply it. Oh no, Apple Z, Control Z. I'm sorry. I'm gonna apply it to my luminance copy that I just made and compare. Let's see. You know, I'm being picky. That's frustrating. So another frustrating standpoint where you have to make a creative decision. Okay, well, it's just too bright in those regions. Even if I undo my brightness levels, I find that this one is different than this one. It definitely is. Sorry, I'm trying to troubleshoot at the moment, but you know, that's what happens when you're not prepared and you decide to make a YouTube tutorial. Okay, well, we'll go with it. Okay, this is my RGB. I created a luminance layer, extracted the luminance. I have this right here, so I don't need that anymore. So now you have your luminance data, and you have HA data, and then you have your color combined data. So now you can go up to process and go right over to LRGB combination, select HA starless L, because you'll have an L for luminance after you extract the luminance. Oh, and one other thing, I'm sorry. Before you run LRGB combination, what you can do here is convolute this image, your color image. And what that does will effectively reduce it of all color noise. You know, I like to just go like standard 3.0. And as you'll see, it'll blur this image. Pretty much gets rid of a lot of the noise. Here's before, after. Okay. And now I'm gonna overlay my HA data. Sorry, there was a bit of a hiccup there, threw me off track. Not sure why they didn't, it extracted the luminance and it was a bit, didn't look the same, but that's okay. You move past it. LRGB combination, I like to run chrominance noise reduction, but, I'm gonna see how this looks with, just default settings. This shouldn't take long. It'll take a bit longer if you add chrominance noise reduction, so we'll see what this looks like. Okay. So it combined the two, and to be honest, it looks pretty damn good. All right, let's do Control Z. That was before, and that's after. Before luminance, after luminance, and I'm pretty happy with that. So actually, I'm going to keep this as is. So now, what you want to do is we're going to save this image and we're going to upload it into Photoshop. And we're also going to go back to our tricolor star image. And after you save it, you can make some color adjustments because the color here will slightly affect this color in Photoshop. So I kind of, I try to make this color a bit more, similar to this color, just so when you combine the layers in Photoshop, the green tones don't, come out in the image. So this, I'm just going to go to histogram transformations, and we're going to be editing this one, and I'm just probably just going to bring down the greens, or you know what, I'm not going to touch it, and we'll see how it looks. So disregard that last comment. So we're going to save this image, and then we're going to make sure you have this image saved as well, and we're going to be uploading both into Photoshop. And again, we're going to be using this raw combined image to add the stars into Photoshop. So go ahead and save it, and I will meet you into Photoshop shortly. Okay, so we're in Photoshop now. I haven't uploaded anything. I'm going to go ahead and upload both of these photos. I have my combined stars, my combined image with the stars, and my final color data without the stars. I'm going to head and open them. It's going to open in two separate photos, and the next process is pretty easy. I'm not too well trained in Photoshop, but basically all you're doing is you're going to select your your image with the stars, Control All, copy it, go over to your color combined image, Control paste, and so it's going to layer it right above it. I like to go and use, to introduce the stars, I go to the blend mode right here. Default it says normal. I like to go down to lighten. Voila. With, without, with, without, with, without, with. And honestly, at this point, I think I'm finished. I'm going to go ahead and crop out the edges. Hit enter. And I like to right click on background, merge visible layers, and now, you know, I can go to color adjustments, selective color. Let's see if we can increase the cyans bit. What does that look like? Okay, so yeah, now we're really editing this orange region down here, and that's, you know, completely up to you. I kind of like it vibrant like that, you know. Go whew. No, don't do that. Again, creative decisions. I think the background might be a little bit purple. I like to go to adjustments, and instead of selecting a color, go to neutral and see where that gets you. Cyans get me to red, magentas. Okay, if you increase the magentas, you kind of get rid of that purple, as you can see, and it's so hard to make a decision at this point. You know, every color palette can be, you know, ooh, yeah. Okay, let's see. Oh, I like that. Okay, and then the black. Okay. All right, again, it's, you know, I'm getting myself all psyched up. All right, vibrance, no, too much. Okay. Okay, so that is my final image. I'm just gonna, you know, flatten image, file, save as, you know, and this is pretty much my, I'm gonna, you know, it's gonna be my new workflow for most narrowband targets, but like I said, it's hard to use AI denoise well. It's very picky. Some images it works really well with, some images it doesn't work well with. For these diffraction spikes, especially in Starnet, you will get gradients left over, and I will show you exactly what I mean by that. Let's go back to PixInsight, where I have my starless image. I know specifically it didn't get rid of the gradient spikes, you know, or I mean, sorry, the diffraction spikes. You can see them right here. You can clone stamp that out in Photoshop, especially you have a lot of them. Clone stamp them out in Photoshop, and then combine your stars, and, you know, it'll reduce the halos. But mostly Starnet is for refractors. If you're trying to do Starnet in narrow and LRGB, the star spikes are usually much more drastic, and narrowband they're pretty muted. So Starnet does a decent job of taking them out, but for the most part, it's for refractors. So yeah, we went through image prep, getting our image uploaded, star aligned, stretched, and we went through Starnet, put our starless images through Topaz Denoise, and then we uploaded our starless images back into PixInsight, where we, you know, did dark structure enhance, some extra, you know, sharpening, and then we finally combined them in Photoshop to get a final image. So I really hope you guys enjoyed. If you have any questions at all, please post below in the comments. I will, you know, I get to all of my comments. I will be more than happy to answer any questions. If you have any comments, you know, constructive criticism, I'm open for everything. So again, thank you again so much for tuning in, and hopefully I can have a couple other videos, post-processing videos here in the future. If you have any recommendations, please let me know. You know, I'm not, you know, I'm not too secretive about my post-processing, you know, my workflow. I find that it's helpful for me, so I upload it so you can improve your images, because, you know, to me that's really what this is all about, you know, spreading the passion of astrophotography and just really trying to, you know, get the best out of your equipment. So thanks again for tuning in, and I'll see you again soon.